Hello and welcome to the Building Sociology Poddy, where we talk about better buildings to live and breathe in. Today, I am joined by Marcus Strang, Technical Lead for Passive House at Hip v Hype in Melbourne, teacher at the APA and researcher at the University of Queensland. Marcus is a passionate advocate for sustainable design and is one of only 5 Passive House certifiers in the whole of Australia. Marcus has a highly technical mind and a very patient nature to boot, so he is an extremely valuable resource in this highly specialised field. Marcus is a great teacher, mentor and consultant, and I enjoy working with him on our certified Passive House projects at Climature. So I am pleased to welcome you today to this podcast for a chat, Marcus.
Thank you very much, Jessica. That's very kind, and I really enjoy working with you as well.
Excellent. Okay, so let's just grease the wheels for the listeners who might not know you or be as familiar with your work as I am. Could you explain a bit about what you do and what Passive House certification involves beyond just basic energy efficiency?
Certification by a certified is mandatory for a certified passive house building, so it's completely up to the owner to make the choice to target certification. And the key benefit of engaging a certifier is actually primarily for quality assurance, as the certification process proceeds from the knowledge that errors and omissions can occur from every human interaction. Therefore, it should be seen as good professional practice that counter-checking is carried out through a rigorous independent third-party review process with the sole purpose to secure that the best possible outcome. So if a building is just passive house principles or an eco-friendly home, it won't really undergo this rigorous certification check, and without it, none of the passive house outcomes are certain. So unfortunately, it's probably likely one, if not all, of the passive house outcomes won't be met in those non-certified builds. So if certification is not pursued, compromises will likely be made accidentally or by design during the design or delivery, leading to subpar outcomes for the client. Not getting it right locks in these mistakes for quite a long time. So for these reasons, I always highly recommend engaging a passive house certifier so that they can be assured the final passive house excellent energy efficiency, more thermal comfort, appropriately sized systems, and a high degree of acceptance by users. I'd also just quickly add there as well that in my experience, when people certify, it's to get value out of the effort they've put in and to hold their contractors to account. And when certification isn't pursued, it's often due to the fact that compromises have been made at some stage during the delivery of the building, and it's probably actually no longer certifiable with the passive house standard. That's a bit of an overview of why I think certification is of value.
Yeah, there's no certification process really for National Construction Code projects. There's not as many checks and balances, and I know that's pretty much the sole reason I moved over into this space is because my experience in the building code energy efficiency space left me feeling really frustrated because I came across many projects that were the stages in design and construct and energy assessment were not lining up.
100% agree. Yeah, those things associated with energy efficiency can easily be externalized, and suddenly no one's really considering them or looking at them.
Yeah. So many things. I mean, simple things like window sizes being changed and not being amended on the energy certificate in a living area can have a significant impact on heat loss and heat gain. And people just shrug and they don't even know they need to have that taken into consideration in their energy assessments. And this happened time and time again for me. And I was just, things like on the plan by owner after handover, we would model those on in our energy assessments and they wouldn't necessarily get done by the owner after handover. Things like external shading or things like ceiling fans or floor coverings that all actually impact the star rating outcome. We had no idea if they were really happening on site. We had no idea if the right windows were being ordered or not. I suspect often they weren't. And I think that the star rating certificate, people don't understand, or it's maybe dismissed more than it should be as an actual specification document, as an important document that tells you valuable information about what needs to go into your home. So the Passive House certification process means that you actually get what you designed. Exactly. Why can't we have something like that for National Construction Codes houses?
I guess the intent is there, but I think it doesn't really carry across to practice and into what we see on site, unfortunately.
No. That's not having those, not having checks, not being confident that you're going to get what you designed is, I don't know, does that happen anywhere else? Does that happen in any other industry apart from our industry?
I'd be surprised if it happens to the degree that it happens in the construction industry.
Yeah, yeah. So it's really frustrating. And it's frustrating for the homeowner because they're putting in so much money into these projects and so much heart and soul and effort and time and sleepless nights. And, there's no guarantees they'll
Yeah,
actually get what they're paying for.
exactly.
So you're one of only 5 certifiers in Australia. This is a highly, highly specialised qualification. What was the motivation for you behind becoming a certified passive house certifier, not just a consultant or designer like myself? And how do you actually become one?
So I think some of my underlying motivation in that space grew from a number of key experiences that I had during my master's studies. So just I can remember some really inspiring physics lectures. And I worked on an Earthship for some time, visited permaculture gardens, did as a researcher and a biomass gasifier in Thailand,
You
and
what?
went on a community biomass gasifier. And that was a fun little stint in Chiang Mai. Uh,
Wow.
yeah, it
You
was
might
fun.
have to tell me what that is.
Yeah, so like a gasifier is something that takes biomass like bamboo or like timber from furniture, and takes the methane out and can convert that to an energy source. So it was used as
Methane
like
out
a
of bamboo.
so yeah, fun little project there.
Wow.
Was looking at like a community side thing. Like I was still very much a student, so it
Yeah.
was a fun little research project to actually go over and
Yeah. Wow.
be there for. And then yeah, on exchange in Germany, just touring a lot of highly energy efficient buildings and districts, and they all kind of shaped my passion towards learning about more environmentally sustainable buildings and technologies.
Yeah.
And after my studies, I reached out with Claire Perry, who at the stage was one of two Pascal certifiers. Claire just started her own consultancy, Green Consulting, and then from 2015 onwards, I worked on a whole bunch of different types of passive house projects. And then at Hippie Hype in 2021, I went through certified accreditation training at Passive House Institute after I had the minimum number of certified passive house projects to my name.
What is the minimum number?
So I think they really just want to see at least three. I think at that
Hmm.
stage I had more than that, but I think that's just to show that you had kind of go through that process, were comfortable with the process, and that's I guess you have like a demand of projects that you can follow through with. So yeah, so that was I think really the motivation was for that, for taking that course. Predominantly was allowing me to continue and practice building physics and this kind of leading edge space within environmentally sustainable buildings. And I feel that's a lot of what draws yourself and I'm sure your listeners to this space as well.
Hmm. Hmm. Well, it's pretty special being one of only 5. And what are when you became a certifier, did you start to understand, like, did that increase your understanding of Passive House at all? Like, did you learn more about the PHPP and about the certification process, or were you already across most of it?
I think it's just a learning process. I'm always like I'm sure every project you learn about PHP or about passive house in some way on every single project, and it's very much the same for me as well. Every single project, whether it's small or big or different typology or has a unique element to it, there's always some learning aspect to it. And that's what I really love about it. So yeah, I would still say that continues to this day, and I'm sure and I hope we'll continue progressing, being able to share those learnings with the passive house designers I work through directly or through documentation that I can share and provide.
Yeah, because going through the PHP, I mean, I've got 5, 2 finished and 3 happening at the moment. And the PHP, no matter how many times I look at it, I still feel like it's this vortex of information that I'm never going to fully understand. I'm like,
Yeah,
Marcus, what
I
does
mean,
this
like
mean? Marcus, what does that mean?
that's all good. That's I mean, that's what we're here for as a network to learn from each other. But I think I mean, there's so much that goes into the PHP, and it's a beautiful bit of software that we can open up and delve into. And ultimately, it is just all those calculations we learned through the passive house design course, but then obviously a lot more in there as well. So
Yeah, there's
it
so
is
much
nice
more in
that
there
yeah, that it
than
is
we
an
cover
open
in the
box.
course.
Oh, yeah, for sure.
Yeah, yeah. So, what do you think are some of the most common challenges that you see on the path from like pathway through to certification for passive house projects?
I'd say that the most challenging part of certification is those projects that come out of the blue. So sometimes they might just appear years after we've been engaged as a certifier, where the project is now fully formed, fully constructed. And this can pose some pretty challenging aspects where there might be a number of uh, significant modeling issues that needs to be resolved, or documentation that's not available, or modeling that hasn't been done. And any of those errors could be a risk for non-compliance. So always, yeah, the earlier these experts can be involved, and ideally having those review cycles frequently or earlier would resolve those and give confidence to the client and give confidence to the design team.
Yeah, so that before you start on site, ideally, you should have what's called a design stage assurance letter, which means that you've checked through every tab of the PHPP and you have determined that all the documentation is correct, the modeling is correct, and it's okay to be built exactly as it's been designed and modeled. Are you saying that some
Yeah.
people come to you with a fully built house and say, "Can we certify this now?"
Yeah, or halfway through the construction and like, oh, maybe I haven't reviewed it since the initial review, and as they haven't had that. They haven't done a thermal bridge modeling. They haven't specified windows, or there's just been a limited, um, review there. So
Involvement.
I definitely, that's their design stage assurance letter. That has been something that I've been recommending over the past few years, because I think it is a value add to the client to give everyone confidence and to show that it's proceeding in a smooth manner towards certification, so everyone can rest easy, and we all
Yeah,
know.
I have to say that was one of the lessons I learned early, is getting that design stage letter before you start on site, because there's got to be a lot of really tight communication to make sure that everything that's in that documentation actually gets built. And if your team has any doubt whatsoever, you could very easily miss something.
Yeah, I think it just removes a lot of the inherent ambiguity in the process like this, where you only really get certification at the end, just to provide some, okay, well, this is where we sit, and we're confident that that process is being followed before the final blowout order has been
Yeah.
done.
Yeah.
Yeah, so I
Yeah, for
definitely would
sure. For
recommend that.
sure. I actually think that it makes it easier. I think the passive house modeling makes it actually easier to build a house than a standard project, because everything is sorted out. Like everything is dialed away, everything is sorted out before you start. There's very little ambiguity once you get on site with the certified passive house project. I heard Matt Carlin from Carlin Construction say that once, that actually certified passive houses have economies purely because there's a process on site that is, and the documentation is followed to the letter.
Yep, agreed. And that's Matt's done a lot of passive houses, and he has
Yeah.
his process, and I think that kind of understanding comes from working on a few passive house projects and kind of knowing where to go and step through that process. And yeah, I definitely agree that then we have the correct documentation, we've got everything there. So when the builders do get on site, it makes it really easy for them, because they're not guessing or having to try and formulate some plan because it's already there.
Yeah, and those crucial details are already drawn. They don't have to make it up on site or work it out. There's crucial details that could create a thermal bridge that have been drawn and modeled, and you know that that's going to be correct and it's not going to trip you up. So
Couldn't
yeah,
agree
there's
more.
definitely a lot of value in the documentation process. So apart from people coming to you with not enough or insufficient checks in their sort of modeling and not getting checked along their construction timeline, is there anything in the actual passive house framework that trips people up, especially when they first start? Like what things normally trip people up?
So I think, yeah, having that experienced design team is probably the most difference between teams that kind of just sail through or not. So for teams that take on their first passive house project, having the certifier involved early on to add that guidance is pretty critical for success. Where if they've gone through that process before a few times, then they might not need so much guidance. But yeah, as we're talking about that high quality documentation, definitely differentiates teams that are going to really sail through or perhaps not, where they've looked at that detailing of junctions and formulated that air tightness concept, mitigated thermal bridging, and specified insulation products and other products as well. And so without that level of detail, errors can be much more frequently made. So yeah, and again, touching on the importance of builders, so they're really great at coming up with economic solutions that are practical. So that early contractor engagement is definitely value add too.
Yeah. So basically, it's just inexperience. Once you know this process, it's you don't really get tripped up because everything's pre-planned.
Yeah, yeah. That
Yeah.
risk
Okay.
just continues to fall down. Absolutely.
Yeah. So out of that, your advice would be when you're starting out, just go slow and get the involvement of your certifier at sort of a much higher level than you would need down the track.
Yeah, and I actually think that what you mentioned there about going slow, I think that's a really giving the time that you really do need to kind of go through the PHP, resolve any issues, just giving that time so you don't miss something. I think that's a
Hmm.
really good touch on there as well.
Yeah, and I can attest from personal experience that having you there to check things that I'm not sure of definitely helps, and it's taught me a lot as I've gone along these projects that I'm doing. Yeah, making sure that I don't rush is definitely something that I have learned, and yeah, not
Good to hear.
avoiding things that might seem tricky. Just ask the questions.
That's what we're here for, and it's really is to support and like we all want the project to succeed. And ideally, we're doing that smoothly and quickly. We do want it to succeed and do that and kind of bring it all up together.
Yeah, and often, like, my clients, they want to start on site and they're antsy, they want to start moving, but yeah, in the early stages, it's important to not rush for sure. So this whole Australian climate construction industry, we don't need passive house in our climate sort of saga. How does that perception, or how does our climate shape the way you approach passive house as opposed to European countries?
So, I mean, we all hopefully very aware that passive house projects have to be adapted to the climate in which they're located. So the passive house PHP modeling software really enforces this climate specific design response. So the passive houses in Australia, this climate response can translate to passive houses that don't require such high thermally performing film envelopes as might be required in Europe. While the form factors of our passive house buildings are typically larger and more articulated to reflect our cultural building style compared to European projects. And yeah, I guess probably within that as well, buildings in Australia typically highlight more of indoor outdoor sort of living due to our Australian climate. But again, that's really not a restriction. So in passive house buildings, we can open up the doors, open up the windows when we desire. But when we do close it down, it's going to allow that really high level of thermal comforts and resilience during peak heating and cooling conditions with minimal energy consumption during those times.
Yeah. So the PHP has got climate files the same way NatHost has got climate files. So we're not designing a house for a European climate. We're designing a house for the local climate.
That's exactly right. So yeah, it is a climate specific response, and a passive house at Sydney is going to be different, and it's not going to require the same sort of performance as something in more alpine climates in Victoria. We can be makes it easier, makes it cheaper because it's responding to that local.
Yeah, yeah, yeah. And even a project I've got at the moment, it's in northern New South Wales, where they have a lot of humidity issues. And, depending on how the model is performing and how many windows are open and, various different factors in the PHP, it will trigger the need for dehumidification, which we were discussing today. So, yeah, I think maybe that's something that is misunderstood, that passive house actually has weather files, has climate files.
Yeah, I think that's because of the way the caps are set, just at 15 kilowatt hours per square meter per annum. People think it is so rigid, but because it's
Yeah,
responding to those climate files, it is climate specific, and that's how we do want to build the building because it means that in particular locations you're going to have comparatively large walls, but in very mild climates you can get away with much less. And I think there
much
is
lighter
definitely
walls. Yeah, for sure.
definitely some confusion there.
Yeah, for sure. Now, you mentioned form factor earlier, a second ago. Could you explain what that is, please?
Yeah, sure. So I think it's a pretty key concept of, I guess, energy efficiency in buildings. So ideally, the lowest form factor is just a sphere compared to like its volume. But in a building, like this is why you end up seeing a lot of passive houses, especially early on, that are very blocky, very like the rectangular kind of cube has a very low form factor because it's external surfaces quite like the ratio of external surface compared to the volume is quite small. Whereas if you have really large articulated buildings with wings going out that way and wings going out that way, and garages inside and courtyards and things like that, it's a lot of envelope, kind of surface area compared to the ratio of indoor area. So that's all going to, if the lower that form factor is, the less we need to compromise on the thermal envelope. So it just means we can make that building cheaper for the same energy efficiency. So if you have really, really large articulated buildings, we need to put more insulation in and have higher performing windows for the exact same energy performance outcome.
So it's
The
kind of a
useful,
ratio between, sorry, what was that?
please go on.
It's a ratio between surface area and indoor volume?
Yeah, like the one that Passive House uses is out of the external area surface over the treated floor area. So Passive House has a very specific definition for the TFA, the treated floor area. But yeah, we can also look at it.
Okay. And the lower the form factor, the more efficient the envelope is going to be. And does that have any impact on the heating and cooling demand? Like if you have a more complex envelope and a higher form factor, that makes it harder to achieve the heating and cooling demand requirements. Is that right?
That's absolutely right, because you may have twice as much wall areas, floor areas, roof areas compared. So if you're talking about we can think we can think about a detached dwelling, like a one-story detached dwelling. If you have 3 stories, as a comparison, there's going to be half as many surface areas which are losing heat in winter or gaining heat in summer. There may be twice as much thermal bridges, which we have to consider. So it's
Yeah.
twice as much area for infiltration to occur. So it just on many different levels, simplifying the building, the thermal envelope, and that's really probably one of the key concepts of our standard is a really tight consideration of the thermal envelope, the area between conditioned and unconditioned spaces. I think, like you were saying, once you get that concept, it just makes a lot of sense from the builder's point of view, from the designer's point of view. We're just looking at that separation between the conditioned and unconditioned zones compared to, say, NATO's, which has a lot of spaces which it can be 13 degrees indoors. And I guess there's less of that kind of concept of that thermal envelope being the separation.
Yeah. So, and that's not to say that complicated building can't be certified. It just might be a little bit harder and more expensive.
Exactly.
Yeah. Yeah. Okay, cool. All right. Speaking of climates, you have finished your PhD on passive house in hot, humid climates. Was that a couple of years ago now?
Yeah, I think it 2 years ago. Yeah, it's getting
Yeah.
on already.
Time flies. I mean, passive house is often described as overkill in the general Australian climate, let alone warm climates. So, could you synthesize what your research found in your PhD research? What did you find about passive house in hot, humid climates?
Yeah, so while I would say Australian climate is milder compared to colder European climates, energy demand reductions for passive house projects in Australia is still significant compared to the equivalent conventional building in Australia. So, for instance, for the heating demand, going from a conventional NCC compliant building, so in 7 stars, to passive house still will grant you 80 to 90% reduction for that heating demand and about 50 to 60% for the cooling demand. So that's still a huge chunk, which we can just slice straight off from going to passive house. So I wouldn't
Yeah, right.
personally consider those energy savings being overkill, especially if we're looking at the future with more extreme weather events. But yeah, so then in my PhD research, so that my thesis explored passive house projects in subtropical and tropical climates and showed that several considerations were necessary to optimize thermal comfort and energy efficiency and to try and mitigate those risks against overheating during summer. And that should be prioritized through strategies like external shading, overhangs, blinds, night perch, glazing with low G values, and probably a key one is minimizing internal heat gains while further reducing sensible and latent cooling demands. Can also be achieved with mechanical ventilation units with enthalpy cores, while, as we spoke on earlier, dehumidification systems might be necessary for comfort and hygiene as well. And from a thermal envelope perspective, thermal bridging doesn't have quite the same influence compared to cold climates.
Mm-hmm.
But yeah, a key part of that PhD research was also looking into strategies for moisture safety in high performance multi-story buildings with mass timber envelopes, such as CLT. And some of the findings from that was looking at the control layers, and that the air and vapor barriers should actually be positioned on the external surface of the insulation, which is in contrast to temperate climates where you want that air and vapor barrier on the internal side of the insulation layer.
Hmm.
So yeah, really kind of practical thesis. And I think it has really given me a lot of extra kind of time and to invest into learning more about the passive house standard and building physics in general. So yeah, very happy to have the opportunity to dig into something like that.
Yeah, yeah. And just side note, I should have introduced you as Dr. Marcus Strang. I do
Yeah,
apologize.
that's quite okay. Thank you very much. It never gets old.
No, I don't doubt that. I was going to say about the humidity. I had a guest on the podcast and she had a holiday home in northern New South Wales and it's closed up for 5 days of the week and rented out on weekends. And she discovered recently that because it's closed up and there's no air movement, the whole place has gone moldy inside.
Definitely not a
And
passive house.
definitely not a passive house. And I'm like, oh my goodness. So there must be all this humidity just infiltrating that envelope and getting stuck in there and just sucking up into the plasterboard and all of the porous surfaces and creating an absolute remediation mess for her and her husband. And that to me would be a very good reason to have a certified passive house in Queensland, just to control your indoor humidity and control your building health.
Yep. Yeah,
Right?
agreed. And that's just that you were saying that was New South Wales. So the further north
Northern
you
New South
get,
Wales. So not even like up
the
in the
worse
actual
that's going to get.
tropics, just,
Yeah.
yeah.
Yeah, moisture is a big thing, and mechanical ventilation is huge. And as we build our like some of the CSIRO research that came out recently showed that conventional buildings are now hitting below 5 air changes, which is still a far away from passive house, but it's still at the stage where pretty much all projects should be considering mechanical ventilation.
Yeah.
And if there's no one home, yeah, then I guess that moisture is just going to be sitting in
Sitting in
there.
there.
Yeah. I wonder,
Yeah.
it would be interesting to understand more that those kind of projects and understanding what are the risks there and how can we persuade them to, I guess that's a good persuasion.
Yeah. Well,
Anyway,
she said to me, what do I do? And I was like, oh, well, I think the first thing you need to do is probably get some sort of ventilation system happening in there so it's not stale and stagnant for 5 days out of 7, which is difficult on an existing home. But I suggested some decentralized heat recovery ventilation and improving air tightness, because I thought if it's just sitting there and if there's heat recovery ventilation, mechanical ventilation in the home, improving the air tightness, it'd probably be a good thing, because it should be stopping all of that humid air coming in to the home while it's all closed up, like infiltrating through all the gaps and cracks that shouldn't be there.
yeah, and it definitely just shows the power of constant mechanical ventilation, which is, I think that's one of the big battles for our building physics time, is just
Yeah.
pushing constant mechanical ventilation as opposed to intermittent, which if the owner isn't there for 5 days a week, then there's obviously we're not going to be achieving any sort of minimum air changes for good
No.
indoor air quality. Goods, yeah, keeping that.
Very unhealthy indoor environment. Yeah. Yeah, not good. And it was, yeah, she rented it out. So now she's, can't rent it out because it's not a healthy environment. Yeah, it's just not like disastrous financially and, so humidity control is crucial up in those climates. And I think that just gets really dismissed and overlooked like it's not even a thing.
And this is where so many different kind of experts can come together, because I know you've done some like building biologist.
I'm studying building
So
biology at the moment.
yeah,
Yeah.
yeah. So I mean, that's where all these, we can all converge to essentially the same solution. So yeah,
Yeah. Going through certification, as complex as it is essentially a tick box exercise, just making sure everything is tick, 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 done so that you can relax and move on and build it as it's been designed. What do you think is the most underestimated detail that you've ever seen derail a certification?
yeah. I would just slightly rephrase that potentially as like, so we've got performance solutions and I guess like deemed to satisfy, where that might be more like a tick
Huh?
box ticking exercise. So passive house at its core is a performance standard. So there's many, many different ways that we can achieve the passive house standard. It really just comes down to creativity of the design team. And so yeah, one way may not work for another project and may require, due to clients' preferences, they might be looking at a different approach. But yeah, so I definitely would agree that the passive house standard holistically considers how all parts of the building systems interact together, where the PHP, the central part of the passive house playing, just to synthesize all those different aspects relevant to the energy balance together. Though the accuracy of the PHP modeling does rely on reliable data sheets that pretty precisely resemble each part of that building component. So in some cases, can be challenging to acquire those relevant data sheets for building products and systems. And this has definitely come a huge way in the past few years, but it can still create some significant project pickups. So I would definitely encourage all passive house designers to understand what data sheets are needed for the passive house certification, so they can and also do feel familiar and confident requesting those correct documents. And this is especially relevant for window frame data sheets, skylight data sheets, mechanical ventilation components, if it's not a PHI certified one. So yeah, just kind of understanding what it is and that it is really important for the integrity of the passive house standard. Yeah, requesting that suppliers give over that data sheet so that they understand what is needed and they can see there's a demand there.
So you're saying that the thing you see trip people up most is not being able to prove what they've installed.
Yeah, and they might
Yeah.
leave it really late. So they're like, oh, we're looking at ordering this tomorrow. It's like, oh, well, I haven't actually seen any of those frame data sheets or skylight data sheets. It'd be great to see some of those and like, oh, I didn't realize. But yeah,
Yeah, so
so
you could
like
install
really becoming
like a heat pump without getting the right documentation to prove that it's going to perform in a certain way, and then that could derail your certification.
Yeah, and probably particularly like for window frames, I would
Windows.
say like they're probably the big ones where I mean it's like most. There's a big list of window providers who can give us really high quality data now.
Yeah.
Compared to when I started, where it was much more challenging, and passive house designers had to model up all the frames themselves, which adds
To get
pretty
the U
considerable
values and stuff.
expense. Yeah,
Yeah.
exactly. But yeah,
Yeah,
so
that's
that's
time
probably just
consuming.
one. Absolutely. Yep. So I guess that's just one comment on just being able to show to the suppliers, this is the information I need on that really early stage. That they're, I guess, kind of, so the suppliers are aware of our clients are asking for this kind of documentation. So let's actually invest in getting that model that we can provide it.
When I first started asking for documentation to prove like components that we were installing, I'd be like, I'm building a passive house. Can you send me what I need? I didn't know how to ask for it.
Yeah.
And then you would send me like, needs to be compliant with this standard and this standard. And I was like, oh, okay, I'll send them that. That might make more sense.
Yeah. And this is where like the passive house that like the PHI have really good documentation out there, and passive house criteria is probably one of the key documents there.
So which one is, sorry?
Passive house criteria.
Yeah, yes. That's a good document.
Yeah,
I
I
haven't
mean,
read it
it's
in depth,
very, very
but it
long.
is useful. Yeah.
I would recommend it. It's probably just
Not light reading. Yeah. I'll link it in the show notes for anyone who wants some bedtime reading. It goes into detail with, passive house standard and what the criteria are. So yeah, that's interesting. So this is another reason why it's really important to get that design stage assurance letter to make sure that all of your documentation is correct and you've got everything that you need before you start on site.
It's time for a quick sponsor shout out. Today's episode of the Building Sciology Poddy is proudly brought to you by our amazing sponsors, Enduro Builders and Climasure. A huge thank you to these incredible businesses for supporting the podcast and helping us spread the word about better buildings to live and breathe in. Your support makes this podcast possible. Please head over to their websites and follow their social pages.
You have worked for Hip Hype for a while now, and Hip Hype has quite a reputation for being progressive in design. So in your experience and from your wearing your certifier's hat, what tensions do you see between this kind of architectural ambition and the pragmatism of performance?
That's a really good question. I would say I see both progressive design and performance ambition as working towards the same end goal, creating buildings that are comfortable and efficient and people want to live in them. So I don't, in my view, the tension often isn't the intent or in the intent, but in how these ambitions are translated into buildable, verifiable outcomes. So architecturally complex geometries or extensive glazing can challenge energy efficiency, air tightness, and thermal bridging, but it doesn't have to be this way. Just as a quick story, back in 2023, Ian Wallace, the founder of Hippie Hype, and myself, toured a number of multi-story mass timber buildings in Norway, which is, again, a really great opportunity to have. And it was really obvious from that tour that architecturally beautiful buildings can still be accessible to the mainstream and employ design decisions that lead to good energy efficiency and low cost by utilizing all those first principles of good massing, orientation, the focus on those high performance thermal envelope. So the tensions do exist, but they're ultimately kind of going towards the same goal, ideally. And we can make.
Yeah, and that yet again comes down to early planning and early involvement in all of the people and teams that need to be involved, right?
Absolutely.
Yeah, you can have what you want. You just have to plan for it and get in early. Yeah,
have that team that works together and isn't just happy to pick up the phone and invest that time.
Yeah, that collaboration piece keeps coming up again and again and again. I was actually listening to a podcast, the Mindful Builders podcast today, and they had Amelia Leigh on. It's an excellent episode, and she was talking about the cultural differences between architects and builders, and then the building owner or the homeowner, whoever it is, commercial or residential project. And they're basically from 3 different planets, and somehow they're meant to communicate effectively and understand each other, which can be very challenging. You've got architects who are trained to, I don't know, I'm not an architect, but they're trained to think about form and light and, human scale and, these sorts of how a room is going to impact a person psychologically, perhaps, and builders who are trained to build stuff, and they're often from a long line of builders in their family, whereas architects not necessarily as much ingrained in their identity. And then you've got homeowners who've got absolutely no idea what's going on in terms of like the professional side of building a home, and they have to somehow communicate. And getting those parties, and then you add in all the different consultants that have to come on as well for a certified passive house project, getting everyone to actually align and communicate is no small feat. It's no small
I agree.
feat.
And I think that's where it comes down to that like shared narrative and that shared like outcome, seeing that goal and everyone really getting behind that and also wanting that. Yes, I think it does come down to a bit of a narrative. I guess that's where like that hip fee hike. That's where it's like, okay, I get why it's called hip fee hike now. Having that the story that we can agree with, not believe the hype, but I guess have that
Yeah.
joint venture together that we're all moving towards in the same direction.
Yeah,
I don't know
right.
if
I
that makes
actually have
sense.
wondered what the hip fee hype actually means.
So have I.
Yeah. Yeah, just aligning everybody and making sure everyone's bought in, getting the buy-in from everyone at an early stage. I think we must have said that a few times now in this conversation. It's clearly an important theme. So I think if you're going to take one thing away from this episode, dear listener, it would be that collaboration is extremely important in every construction project, but specifically passive house projects. Beyond certification, is there anything that excites you about where building science is headed in Australia right now, Marcus?
Absolutely. I think the thing that really excites me the most in the high performance building space is the really strong demand for clients that are looking towards deep energy retrofits,
Yeah.
specifically targeting the NFIT building standard, where clients and designers appear to be increasingly value adaptive reuse of existing materials and celebrating the history of what's already there. Another area that's exciting me is projects that incorporating bio-based building materials, for example, hemp, straw, rammed earth, salvaged building timber products, where in partnership with the Passive House Standard, I really think there's a beautiful opportunity there to dramatically reduce not only the operational energy, but the embodied energy of our new and existing building stock.
Yeah, I'm really excited about Enefit as well. I have to say I was a little bit scared of it. But I have a client who is looking into doing Enefit for her new house that she's just bought, and I'm super excited because I think that this house is going to be a perfect case study or a perfect building for the Enefit standard. And seeing it turn from the incredibly leaky, uncomfortable home that it is now into a certified passive house is so possible. And I think that it's just a total game changer for health and comfort and acoustics and, just livability. So
And we have some really beautiful case studies now in Australia that do speak to that benefit of moving through that. And I don't think it's an easy challenge, but I think it's a very worthwhile one.
Yeah.
There are all these added constraints which really just promote creativity and promote innovation. So it's I would love to see more and more of those.
Yeah, now that I've had a few, brand new projects go through, I'm more comfortable with the PHVP. I'm much more comfortable taking on a challenge like a retrofit and a fit project. So, yeah, if you're listening, Amanda, I hope that you can go ahead with your Enefit project. Okay, this to me, this I'm really interested in your answer to this next question. What do you think that, in your opinion or experience, what does the passive house framework not check or quantify that you think it should or could?
For me, it kind of leans on from that last question. So in a way that I think passive house has a really strong focus on energy efficiency, thermal comfort, and well-being, investment. And I think it is good that the passive house standard rigidly focuses on those areas because it does that really, really well. But as the operational energy shrinks, that embodied energy becomes larger. And so the PHP software doesn't natively quantify this embodied energy, but PHI have released what they call the manufacturing energy evaluation tool called MEET. So it's a tool that I've started using on all our in-house passive house designer projects, and I would highly recommend it to all passive house designers as an value add-on for clients to quantify and guide the specification of materials to minimize embodied energy of our passive house projects. I think in the end, we all want the same thing, and tools like the PHP and this MEET tool really help guide us and quantify it. So I think that's a really nice tool that I would recommend people check out and start incorporating where they see fit.
So what's it stand for? MEET.
Yeah, it stands for Manufacturing Energy Evaluation Tool. So it's looking at the energy.
Is it kind of like a life cycle analysis type thing?
Exactly, yeah. So there's some
okay.
limitations there because it's not so broad as like transportation and things like that. So it makes it much easier to just kind of plug into the PHP and quite easily pull out some quantifiable information, whereas like a full LCA study would take a significantly longer period of time. But this is quite useful for kind of comparing different materials within an assembly. So it can be like, what would happen if I have maybe 7 different assembly types, and what does that look like for the operational and embodied energy comparison over a 30-year period? So it kind of allows you to
Brilliant.
compare these different things. Yeah, same and that's always what the PHP is used, very useful for sensitivity studies because it's an Excel file. You can change something, it'll instantaneously update, and in the same way, this file is very useful for that. So you can, if anyone's used to the variance tab in the PHP, it's similar to that and allowing you to compare multiple different materiality and selecting over the lifetime which one's actually going to be the most effective for the total operational and energy output. So, yeah, great little tools there.
That's really interesting. And how do you get that? Is that downloadable from the PHI website?
Yep. Yeah. I think it's might be on Passipedia even, but yeah, if you just Google that MEET, manufacturing energy evaluation tool.
Awesome. I will do that because it was actually something we were discussing at work about carbon emissions and those sorts of things for materials, steel versus timber, for example. So if that's a plug into the PHP, that it would be extremely useful and really interesting. So I'll definitely look at that.
Please
Cool.
do.
What about moisture content of timber?
And what? That's a good question, but what's the question?
It really bugs me. I mean, the thermal bridging calculation, the air tightness, the surface temperature can't be below 12.6 degrees. No surface can be below 12.6 degrees. It's all to avoid a dew point. It's all to avoid condensation and mold. But there's no nothing in PHP or in the Passive House standard that says you have to moisture test your timber before you put your insulation in to make sure it's under 15%, that it's not going to go moldy inside the walls.
So there is a little clause in the Passive House criteria that states like if moisture safety is doubtful, then that's kind of, I guess, reason enough for the certifier to challenge essentially certification if there's like
Really?
issues, or for to request something like a thermal perform like a hydrothermal report or something like that.
Okay.
So in the cases where, like, if it is, you know, if it's CLT and it's been saturated because the windows haven't been put in and it's been raining for days, if there's like issues around the structure, then a certifier cannot issue certification if it's, if there's risk.
They're doubtful.
Yeah, and that might include certain building assemblies where the certifier might think that there's risk for interstitial condensation. So then they might request the Wolfe report to check over the long term if there is in fact moisture going to be accumulating within that wall assembly. So it's not quantifiable within the PHP because it's an Excel file, but this is where these expert evaluations become useful as well. So the client.
It would be pretty easy to just get a pin meter, a moisture meter, and, ask for, say, I don't know, 10% of frames or, 20 studs to be tested and then photographed, on the day the insulation goes in. Or, you have to prove that a certain stud has now dried to a certain point. That would, if I could change the PHPP, if I could change the Passive House standard, that would probably be something I would change, because so many, frames get left out in the rain all the time. And obviously the membrane goes on as quickly as possible. It's not always quick enough. Timber packs arrive wet or they arrive already moldy. And this, to me, goes against everything that Passive House is trying to achieve in terms of being a healthy building standard. So, yeah, if I could change one thing, that's definitely what I would ask for.
Yeah, so I think this is where if you have projects where you think it might have been like rained and you've gone in to check it and like, hey, there's actually water pooling, then definitely let's talk and like figure out some strategies to dry the building out. Does that mean having a dehumidifier? Does that mean getting a broom and just physically moving the water out? Like, check my thesis. It has many strategies in there around moisture safety.
I will actually.
Yeah.
Yeah.
So happy to talk on moisture safety anytime.
Yeah.
I think there is some, the PHP can't, and the Passive House criteria can't consider everything. But yeah, absolutely right. We don't want more, like a key part of that is a building that's not going to equate to mold growth in the long term, and we definitely don't want that in our building. So yeah, we want to work together to figure out strategies if rain has been occurring, and that also is the builder. The builders probably, they're responsible if it's been raining on site and they're now sealing the building up. That's probably their liability. There's everything saturated. So it's worth thinking about maybe putting a dehumidifier in or figuring out some strategies to get it below 18% moisture content, whatever we might deem as safe for it to still continue to dry out once the intent airtightness or weather resistant membranes all sealed up. It will restrict some drying, but it still does allow dry out even once it's all sealed up, because we have our vapor permeable weather resistant membrane. Once the building's occupied, should be a bit warmer and it should be drying out naturally. So there is definitely some tolerance there, but especially where there's novel wall types and things like that, has that been checked to still have a dry out capacity? I think is important. Yeah, no, you raise a really good point there, and happy to discuss any of that.
All right. I'm going to go through and read your moisture mitigation strategies in your PhD and come back to you.
Excellent.
I'm actually also going to link a cheap moisture meter, a pin meter, in the show notes. If you're a builder who wants to check the moisture content of your frames before you insulate and clad to make sure that you're reducing your mold risk inside your walls, please go and have a look at the resources I put in the show notes, because it's something that is so easily overlooked and could impact health quite severely. There's a project here in Adelaide I've posted on my Instagram about, and the frames are just black. It was a job where the builder went bust, and this is not a passive house project, but the builder went bust. It was out in the rain for, I don't know, 1, 2, 3 winters, maybe more. And I drove past one day and I was just flabbergasted. So I stopped, pulled over, had a look, took some photos and videos of it. And lo and behold, a year later, it's nearly finished and people are about to move in and the frames are black. So
This is where sequencing is so critical.
oh,
Sequencing is anyway a big part of the passive house standard, but sequencing in regards to avoiding moisture risk,
Yeah.
to getting that weather resistant membrane on, not just opening up the windows before the rough openings, like
Yeah.
cutting open the weather resistant membranes before the windows have arrived. We want to keep that sealed so rain just can't dump in until.
And the reason I actually noticed this project was because it had, like, I don't know, tarps or something, and they were just shredded hanging off the frame. And so that's what caught my attention. And it wasn't until I got closer that I realized how black the frames were.
Yeah, wow.
And of course, they weren't protected from the weather. And this project, as soon as the builder went bust, I don't know, they didn't understand how to mitigate the risk there. But if they had got membranes on that project, it could have sat out in the rain for 2 winters and without a problem. So yeah, you're 100% right. Sequencing, getting that membrane on your timber frames ASAP is so crucial. And then testing the moisture before you insulate to make sure that the packs you've got are actually dry.
Yeah, that's
So
scary
easy.
thought to me that people are leaving insulation packages out in the rain open. That's a pretty scary.
Yep. There was another project on the Esplanade here where they had the roof blanket rolled out on the roof and all the sheets were on. So the bulk insulation on the roof blanket was just getting saturated by the rain. And then someone else come along and put a roof sheet over the top of it. And how's that going to dry?
But hey, like these kind of projects, like at some point, that someone's going to realize that, I mean, these aren't passive house projects, but
No.
that's like then someone's going to be liable. It's going to be a big old thing. But yeah, it's an interesting topic.
Mm.
Yeah, it really comes down to yeah, I mean, if you have projects like that and they're excellent case studies, I guess. These are things like the things that people do wrong and you don't need to, they're as helpful as the ones that we do right.
All right. So I have 2 more questions for you, Marcus. The first one is, from your experience, what practical steps can builders and designers take if they're new to passive house but want to start moving in that direction in terms of educating themselves and their potential clients? And we talked earlier in the session about how this is kind of scary and more difficult when you start out. So what's the best way for people to start out?
So I would say for builders and designers who are new to passive house and but wanting to start moving in that passive house direction, it's very fortunate that we have a lot of great resources out there. And as a start, I would recommend Australian Passive House Association's Passive House Designer course for designers and the tradesperson course for builders. And that really will give a really tight network to help support one another and a lot of good resources to get you started in this world. So probably that would be the first port of call if they haven't already gone down that road.
Is there anything to add to that? Or is that?
Oh, that's probably the main one I would say. I think
Yep.
Yeah.
Okay, cool.
Is there, as a designer, I guess yourself, is there things that you feel that you would add to that if they were wanting to educate themselves for clients?
Well, when I went through the course, it was nearly 4 years ago now. So I think it's changed since then, and I didn't go through APA. From what I've heard, the course has changed now to have more information about the actual PHPP. So we were taught a lot about all of the passive house principles, not principles, all of the passive house, like the calculations and all the science and maths behind it. But as far as actually using the PHPP, I never opened a PHPP when I'd finished the course. And I'd also never modeled a house in design PH in order to import it into PHPP. So that for me was a big missing piece. And I did your design PH course, and I also did one for the Elsie Wang did, because I felt like I really needed a lot more help to get that knowledge and experience. And the thermal bridging, if I didn't have in-house training on thermal bridging, and I also reached out to Elsie for that and got in-house training, I don't know how I would have learned how to use Flixo and do a thermal bridging calculation. So the Flixo videos are kind of useful. I found them hard to follow. There's no audio. It's just literally showing you what to do on a screen. I found them quite slow and frustrating. So I think just the actual practical training on how to use the PHPP, how to model and design pH, and then how to do a Flixo thermal bridging calculation or a therm calculation or whatever you want to do, is pretty important. And I was lucky enough to have people around me to help me.
Yeah, I definitely agree that the Passive House course is just the first step
Yeah.
into this world, and there's definitely a lot of education that comes in after that, such as those workshops. And we have been trying to, like you were saying, we've been trying to migrate a lot more of that PHP work into the designer course and more kind of some of the hands-on calculations, trying to like front end that, I guess. But yeah, a lot of those design PH workshops, and bridging workshops, or just having that network that you can speak to and learn from, I think it's pretty critical. And yeah, it all comes down to who you know and being able to get support from that wider community. It's really important.
Yeah.
And as you know, everyone's very friendly and everyone wants to help. And yeah, I'm always astounded by our fellow Passive House designers and everyone involved in that world. It's very generous.
Yeah, I'm never fails to amaze me how, yourself, people like Elsie, and everyone in this community willingly put aside time at short notice to help and answer questions. It makes a big difference. So thank you. Okay, final question, and I ask this of everyone who comes on the podcast. Out of everything that you've learned in your career, what would be one takeaway that you want the listener to know?
I would say just start the journey. If you're thinking about it, just get into it. And I think a really good way to start it is by experiencing it. And starting Passive House Association, have an open day coming up. So I think seeing and feeling that difference is critical to be able to kind of explain that to clients, or for your client being able to feel that difference yourself and really understand how Passive House translates into reality. So seeing is believing. That's probably what I would say that'll be the main takeaway. And once you understand it, then it's really hard to consider anything else really, as being kind of what we want to live in.
Yeah, you're right. Seeing is believing and feeling is believing, because the Passive House feels different. It doesn't just look different. They don't actually look all that different unless you can got X-ray vision and see inside the walls.
Well said. Feeling, absolutely.
Yeah. Cool. All right, Marcus, that's it for today. I'll let you get on with your evening. Thank you so much for your time.
Thanks, Jessica. Thanks.
All right, see ya.